In this video, I'm going to talk about pivoting for matrices. Pivoting is a process that transforms a matrix from one into another. In pivoting, there's a pivot entry, often denoted by a star or an asterisk. Once we fix a pivot entry, then the row that the pivot entry lies in will be often called the pivot row, and the column that the pivot entry lies in will be called the pivot column. The goal of pivoting is to get this into a new one such that the pivot entry becomes a 1, and all other entries in the pivot column become zeros. For pivoting, we can basically pivot at any entry in a matrix with only one restriction. Please bear in mind, we can only pivot at a non-zero entry. In other words, if this is not a 4 but a 0, then you cannot pivot it. Whenever this is not 0, then you can always pivot at this entry. For pivoting, there are two major steps. Step number 1 is to multiply the reciprocal of the pivot entry to the pivot row. What does that mean? Well, let's take a look at this example. This matrix has 2 rows and 4 columns and is called a 2 by 4 matrix. In this matrix, I can pivot at any of these 6 entries because they are non-zero, and we cannot pivot at either of these 2 entries because they are zeros. Let's say I want to pivot at this particular one at this moment. What we are going to do in this step is to multiply a reciprocal of this entry to the entire row, the pivot row. So first of all, we have to put down an arrow to indicate that we are going to transform this matrix into a new one. Please do not use an equal sign, because what we are going to get is a new matrix different from the original one. The reciprocal of this entry is 1/2. And the pivot row is the first row, so we use the symbol R1 to denote row 1. The second row is not going to be changed, and hence we are going to copy it first. The first row is going to be changed by multiplying 1/2 into it. What does that mean? It means that every single entry in R1 will receive the extra factor 1/2. So the first entry is 1/2 times 1. That means 1/2. The second entry is 1/2 times 2. That means 1. The third entry is 1/2 times 0, 0. The last entry is 1/2 times 5, 5 times. This finishes the first step, multiplying the reciprocal of the pivot entry to the pivot row. And you can see that after this procedure, we make sure that the pivot entry turns into a 1 because we are multiplying the reciprocal to itself. In the second step, we are going to try to get these zeros in the pivot column. But how? We are going to do it by adding or subtracting rows. This is slightly more complicated, and I'm going to go over it very slowly. So let me try to continue with this particular example. We are still pivoting at this one right there, and we want to turn this entry, -1, into a 0, because this is our pivot column. But how can we do it? Well, we are going to change this entry into a 0, and this entry is in row 2. So we first put down R2, indicating that we need to change R2, the row number 2. And we always put down the pivot row, R1, behind. And the way to change -1 into 0 is +1. And so we are going to put +1 times right there. What does this mean? That means that R2 is going to be changed into R2 plus 1 times of R1, and 1 times of R1 means simply R1. So this notation means only R2 is still going to be changed, and therefore I'm going to copy the first row right there. R2 will become, so we try to add the new row, the entry 1/2 to 0. We get 1/2. We get add 1 to -1, we get 0. We add 0 to 4, we get 4. We add 5/2 to 2, that's 9/2. That's exactly the operation we are going to perform, because R2 plus 1 R1 is going to add up the corresponding entries. This is the end of this procedure, because I have successfully changed every entry in the pivot column into a 0, apart from the pivot entry itself. And in fact, this finishes our goal. We have turned it into a new matrix such that the pivot entry becomes 1 and every other entry is a 0. So this is the end of the pivot procedure. Let's try to do another example to make sure that we understand the procedure. Let's say this time we are going to get a 3 by 3 matrix with 3 rows and 3 columns. This time we can basically pivot at any entry because there is no 0 here. So we can pivot at any entry, and let's say we want to pivot at this particular entry this time. The first step of pivoting tells us that we should multiply the reciprocal of the pivot entry, i.e. 1/3, to the entire row, i.e. R1. And what we are going to get, the second row and the third row are not changed, so let me copy them. The first row will become 1/3 times 3, which is 1, 1/3 times 4, which is 4 over 3, 1/3 times 1, which is 1 over 3. Step 2. We need to do some adding and subtracting of rows to make sure that these entries are turned into 0. How? Well, we need to make this entry a 0. That means that we are going to change R2. And we are going to use the pivot row R1 to do it. How can we change 2 into a 0? We need to do subtract 2. So we put down -2 right in there. In this step, we are going to only change R2, and so first row and the third row are going to be copied. When we do the second row, it's fairly complicated because I need to multiply -2 to R1 and then add to R2. And so here, I would suggest everyone to make an auxiliary row. What does that mean? Let me put this into a box. This is going to be an auxiliary row. So -2 times R1, we will get -2 times 1, -2, -2 times 4 over 3, -8 over 3, -2 times 1/3, -2/3, and this is our auxiliary row. You will notice that -2R1 is exactly this row. And what we are going to do is to add this to R2. So we will do it entry-wise. -2 plus 2, 0. -8 over 3 plus 2, -2 over 3. -2 over 3 plus 3, 7 over 3. And we're not done yet because we still need to turn this into a 0. And what we are going to do is to change R3 because this entry is in the third row. And we need to always use the pivot row to do it, so we always put down R1 there. How to change -1 into a 0? We need to do +1. This notation tells us that the first and the second row are not going to be changed. So I'm going to copy them. In the third row, it's going to be adding 1 times of R1. That means just add directly the R1 into it. So 1 plus -1 is 0. 4 over 3 plus -4 over plus -4. This is -12 over 3. So plus 4 over 3 is -8 over 3. And then 1/3 plus 2 is 7 over 3. This is the end of the pivoting procedure because I have turned the 3, the pivot entry, into a 1, and all other entries in the pivot column are zeros. Let's do one more example. Let's say we are working on the same matrix right there. But this time I'm going to pivot at a different entry. Let's say I want to pivot at this particular entry. According to step number 1, we should multiply the reciprocal of this entry to the entire row. So the reciprocal is 1/2, the entire row is R2. The first row and the third row are not going to be changed. So I copied them. And the second row, every single entry is going to receive 1/2 into it. So 1/2 times 2 is 1. 1/2 times 2 is 1. 1/2 times 3 is 3/2. Next, I'm going to use this particular row to help us to make sure that these are zeros. How? First, I need to change this entry. This entry is in the first row, so I put down R1. I need to use the pivot row R2 to do it. And how can I change 4 into 0? I need to do subtract 4. The second row and the third row are not changed, only the first row is changed. So let me copy the other two rows. And this time it's fairly complicated again. And so let me try to put an auxiliary row here. -4 times R2 become -4 times 1, -4. -4 times 1, -4. -4 times 3/2 will become -6 because 2 and -4 has some cancellation there. This is our auxiliary row, and we are going to add this to R1. So 3 plus -4 is -1, 4 plus -4 is 0, and 1 plus -6 is -5. We need to do one more thing. we need to make sure that this is also 0 because we are pivoting at this entry. This is our pivot column. This is in the third row, so I put down R3. The pivot row is R2. How can we change -4 into a 0? We need to do +4. Only the third row is going to be changed. So let me just write down the first and the second. This time I need to do 4 times of R2 and then add to R3. And so I'm going to put down the auxiliary row again. 4 times of R2 is 4. 4 times of R, this entry is 4. 4 times this entry is 6. And this auxiliary row is going to be added to R3. And what we are going to get is 4 plus -1, 3. 4 plus -4, 0. 6 plus 2, 8. And we are done because we have turned this pivot entry into a 1 and we make the pivot column or other entries being zeros. Just a quick remark, right here I did not do any auxiliary row. Why don't I need to do so? It's because the auxiliary row is simply 1 times of R1, which is this row. 1 times of R1, 1, 4/3, 1/3. You may do so as well if you are not comfortable with not doing it, but we don't have to because basically we're just copying this row here. So all I need to do in this step is just add carefully the first row to the third row. 1 plus -1, 0, 4/3 plus -4, -8/3, 1/3 plus 2, 7/3, etc. Instead of copying this row again and do the auxiliary row. If you have any other questions, please ask me during the lecture. Thank you very much for watching. Bye.